Okay, so this is cluster analysis data modeling that we can use. But before we proceed, let's take a look at the diagram from previous session. Let me stop this one first. Okay, can you see the slide? Okay, so if we look at the group of data modeling that we have this chart. So the center is the machine learning here. So basically what we will study in this course will be supervised, unsupervised, and some part of the artificial neural network, and also ensemble learning. Okay, so today is the first lecture on data modeling that we will focus on unsupervised, clustering, and we look into the k-means. Okay, so that is where our focus now. So if we look at the definition here, so clustering is actually finding groups of data. So you will learn about how different cluster tasks perform the clustering, and how do we define a group? How do we decide what is the best quality of clustering result that we can get? And we also learn how to do step by step on performing the clustering. Okay. Am I out? Okay. Okay. So when we try to understand the concept of clustering, clustering is actually grouping your data into groups or cluster based on the content of your data. So basically, you don't know how many group you have, but based on the quality of the cluster analysis, we can define what is the best number of cluster. Okay, so so the way we perform the clustering is we initially state that okay, how many cluster we want, 3 cluster or 5 cluster, then we will perform the clustering technique, and we look at what is the quality of the cluster. So we will try any number. Okay. So what is the application of machine learning? We can use the application of clustering. We can use them to perform customer segmentation. So basically, we divide them into group based on demography or purchasing history. Then we can perform the targeted marketing campaign, because different segment or different cluster may require different product. Okay. We could also use this one for looking at abnormal behavior, because if we know that they belong to certain cluster, so there shouldn't be any outlier. So outlier referring to abnormal pattern which is outside the cluster, okay, outside the group. So these are those data which are not matchable to the cluster or to the group. So we can use this one to detect abnormal behavior. And the last one is we can use them to simplify our large data set. So instead of having multiple features or multiple column, we can use one column, which is the cluster ID, to represent all the feature that we have. Okay. You may stop me if you have any question, or you can write down in the chat. Okay. So one of the major tasks of clustering is we try to group the individual based on the background. Okay, so this one is useful because it will facilitate professional networking and collaboration. We want to group them based on their background, based on their expertise, so easy for them to mingle around and then chat and to collaborate. Okay, so when we talk about clustering, we are looking at how compact the cluster is, how close they are together in one cluster. Okay, so we are looking at the intra-cluster distance. How do we make sure that our cluster are very compressed, very compact? So we are looking at the distance between the member within the same cluster. And at the same time, also, we are looking at the distance between clusters. So we want to have clusters that are separated far away from each other. Okay, so this one will tell us whether we get a good cluster result or not. Okay. For instance, we have these two. So on your right-hand side, we have three clusters, but they are not very compact and they are not separated far away compared to the cluster result on your left-hand side. So what we want to say here is that we have good clustering result here because they are very compact and they are separated far away. And this is good cluster also, but not as good as the first one. Okay. So our objective is we want to have cluster result which have very compact and separated far from away. Okay, how many cluster you see here? Can you type in the chat box? How many cluster we have here? 2, 3, 4. How many? 6. 2 cluster. Yes. Okay, we can verify what is the best number of cluster if we have some indication or some measurement that we can use. Okay, so you are in what? In mathematics and computer graphics, right? So you use your mathematics skill in order to measure what is the quality of the cluster result. So based on our observation, it could be 2, but how do we verify them? Okay, so it could be 2, or it could be 6, or it could be 4. But this is the question that we want to ask. What is the best number of cluster? We want to have some kind of measurement or some kind of mechanism to verify which number of cluster is the best one. Okay, so we will learn this one, but first we need to look at how do we form the cluster first. How do we perform the clustering task? Okay, so for us to perform the clustering, we have to know what type of clustering we are doing. We have 2 types of clustering. The first one is called partitional clustering, and the second one is called hierarchical clustering. Okay, partitional clustering is non-overlapping. Let me give you one example here. So this is partitional because we divide them into groups. Okay, there is no overlapping cluster. But if we compare with hierarchical, okay, this one is in the form of dendrogram. So they call it hierarchical clustering, in which we can see depending on how many clusters we want to have. For example, if we want to have 3, then we cut the dendrogram here. Then we have 1, 2, 3. Okay. So if we look from the top, we will see something like this. So this is like overlapping cluster, right? So it depends on how many cluster you want to see. Okay, for example, if we look at here, which is the 2 cluster that we have here. Okay. So this is hierarchical clustering, but we will look into partitional clustering only, which is the non-overlapping clustering. Okay. So how do we perform the clustering? Basically, the first step that we need to do is we need to decide what is the number of cluster. So normally they said that you start with this. If you have 100 data, so you take the square root of that particular data, which is 10. So you start with this number. Okay. So k equal to 10 lah. Okay. So but somehow you need to test, because maybe 8 number of cluster or 12 number of cluster or 6 or 14 number of cluster will give you better. Okay, but you start with the square root of the number of item that we have. Okay. Okay, let's suppose we have decided, okay, k equal to 3. So that means 3 cluster. So what happens is that you pick the center of the cluster randomly among all the data that you have. So if you have data something like this, you have multiple data. Okay. So if you want to form 3 cluster, you pick randomly from the data that you have. So you say, okay, I take this one as the center, this one as the center, and this one as the center. So this is the k equal to 3 refer to 3 center that you will select randomly, and you will assign the remaining of the data to the nearest center. So basically, okay, I will assign this one to this guy, this guy. So this one is going to this guy, this guy, this here. So by assigning them to the nearest center, actually we are forming a cluster here. Okay. So the next stage is we need to find the center of this cluster again in order to update the next center. So over here we say, okay, once we found the center, then we will assign all the other points to the closest centroid. Okay, and then we recompute the centroid, meaning we find the new center from the cluster. Then we do it again until there is no changes of membership. If we go to the illustration like this, okay. So for example, this is the original point. This is the actual data that we have. If we get clustering results like this is optimal clustering. So good enough compared to the original point. This is optimal, suboptimal clustering because we did not get what we're supposed to get. Okay, but good enough lah. Okay, so when we have this original data, so initially we don't know what is in this data. We can see that there are 3 clusters. Okay, so let's suppose I say we set k equal to 3 from the data. So for example, like this. Okay, I pick my 3 center, then the remaining data I will assign to the closest centroid that I have. So I will have this, right? So we have this cluster and this cluster and this cluster. Okay. So the next stage is I need to update the center. The center could be here or the blue one, and the new center is this one. This one. How do we find the center? We basically find the average among all the members that we have in that particular cluster. Okay. So so that means this center moving towards here. So we will repeat again. We assign the remaining point to the new centroid that we have. So if I may remove this, you will see the illustration something like this. Okay. So the center will move to the most appropriate position. So we will end up something like this. Okay. So notice that when we pick the centroid from the data, we pick them randomly. Okay, so it depends on which center, okay, which position or which location in the data that you get. So it will give you different result. So it's best to run them few times, then you get the best quality one. You keep the best quality one. Okay. Okay, let me show you how do we apply this one in the real world situation. For example, we have 7 documents here. So this is a document that contain term that they have. So this is the term that consists of all the word or keyword that exists in this document. So the number here referring to how many times they exist. So for example, this one, term 1 exists 3 times in document 1. And at the same time, also term 1 exists 2 times in document 2, 1 time in document 3, and so on. Okay. So given that we have these 2 data, no, 7 data, so we need to form 2 clusters. So let's suppose k equal to 2. Okay. So we will select randomly from the data that we have. So for example, we have these 2. Okay. And what we need to do next is we need to assign the remaining data to the nearest center. So basically we are going, what is the distance between this row of data to this center and this one? Okay. So in order to determine what is the distance, we use the Euclidean distance. Okay, so the Euclidean distance is defined by, okay, this is the Euclidean distance between x and y. So basically, we are looking at the summation of the differences between x and y. So they are vector. Oh. So this is y. Okay. So the summation of the differences between x and y, the summation of the differences of x and y, and we square them. Okay, we want to eliminate the negative value, so we square them. So for example, the differences between document 1 and document 3. Okay, so we take this one, 3 minus 1, and then we take the square, plus 4 minus 2, and we take the square, plus 5 minus 5, and we take the square, and then 1 minus 3, and we take the square. So we sum up all these differences, and then we get the square root, we get 3.64. So this number refers to the differences between document 1 and document 3. So now this is okay. So the next one is we want to measure the distance between document 1 and document 6, because we want to decide they're closer to K1 or K2. Okay, So we repeat again here, for 3 minus 6 here, and then 4 minus 8, 5 minus 5, 1 minus 2, and we sum all the differences and we take the square root, we get 5.1. So since document 1 is closer to document 3, then we say, okay, document 1 will belong to the same cluster with document 3. Okay, so next test will be, you will repeat for document 2 again. So we take the calculation here. So we found that document 2 nearer to document 3. So we assign document 2 to cluster 1. Then we repeat again for cluster. Actually, we perform the finding what is the distance between document 3 and K1. But since document 3 is the center, then they automatic within the cluster 1. So we do it again for document 4. So document 4 is nearer to K2. And then we do it again for document 5. Document 5 is nearer to the first cluster. And then document 7 belong to the first cluster as well. So we have this 2 cluster. Okay. So the next stage will be, because we finished with the assignment of all the point already to the center. So the next stage will be, we need to update the center. Okay. So this is the grouping that we have. So 4 with 6, and then the remaining are in this another cluster. So what happens is that we will update the center by taking the average. Let me change this one first. The alignment ladders. Okay. So we have this data. So the new center for K1 will be, we take the average of the green one. So we will have all the number here, and then we divide by 5. Okay, then we get this value. And then for this one also, we take the average. This is for cluster 2. So 4.5, 8.5, and 2. Okay, so this is the centroid, the updated centroid. So what you need to do again, then with this center, we will repeat the whole process again. So we take this one, we take this individual record or document, then we will compare them with the centroid. So we will assign them to the nearest center. Okay. So don't worry, I will give you some assignment about this one. But the idea is, we pick the center randomly. We assign all the point to the nearest centroid. Once we have done with that one, we recompute the center and we do it again. Okay, so we will repeat this process until there are no changes of membership of the cluster. Okay, that means they become stable already. Okay, so the question here is that we have 2 clusters. Okay, so how do we measure the quality of the cluster? How do we measure the compactness? So this sum of square error will give you the impression that how compact is the cluster. Okay, so that means the smaller is the sum of square error, the better is the result of the cluster. Okay, so we will look into this one. So if we say, okay, let's suppose we have 3 clusters here. Okay, so our mission is to see what is the measurement of sum of square error. Okay, the sum of square error determine how compact is your cluster. Okay, So how compact means what is the difference between all the members to the center of their own cluster. So the first step that we need to do is we need to find the center. So how do we find the center? We just simply take the average. Okay, so this is the new center that we have for each of the cluster 1, 2, and 3. And now we use the same formula just now, the same formula to find the, this one is different. This one is, we're taking the differences and we square that particular number. So for this one, we take the difference between this and that. So that is 0.5. And then 4 with 2.5, that is 1.5. 5 with 5, 0. 1 to 1.5 is 0.5. And then this is 0, 0. Okay, we take the square, we sum up, this is the value. Okay, and we do it again for the second one. So this one will go with that. So the difference is 0.5, 0.25. This is, no, not that one. Sorry, this one. Okay, so that one is negative 1.5. So we get that one. And then this one is 0. This one is 0.5. This is 0 and 0. No. Okay. So when we add up the value, we get 5.5. No, 2.75. So this is for the first data. This is for the second data. So we add up this, then we get this one because we have the summation, right? So that is only for the first cluster. We need to do it for all the cluster because we can see from the formula here, we're going from K1 until K. So since we have 3 clusters, we do it again for the second cluster. So similar to this, we compute the compactness. So we will have this and this by looking at the differences of each of the data that we have. So we will do this. Okay. And we take the square of that differences and sum them together. And we get 26.25. So similar to this, we get, this is, the difference is 2.5, this is 3.5, this is 1 point, no, that is 0.5, this is 0.5, this is 2.5, this is 1. And we get these two values, then we add up them together. Okay, and this is for the third cluster. Then finally, the sum of square error is basically adding all this value. Okay, so this is the total. So what we can do is we take this value and we compare with the other result of cluster. So the aim is to minimize the value here because the smaller is the sum of square error, the more compact is your cluster. Okay. So this is another example. So we pick the 3 center at different location, but this one will give you the suboptimal results. So that's why they said you need to run a few times and you keep the best clustering result. Okay. So on this slide, they're saying that, okay, since we are looking at how the chances of us to get the best result will be, the probability is 0.0003 because they're looking at the number of ways to select one centroid from each cluster divided by number of ways to select K centroid. So this is more into the probability of having the good result, which is 0.0036. So that's why you need to run a few times. Okay. Okay, so this is another example. This is for 10 cluster. Okay, so when we select the 10 random number, 10 random centroid, they will eventually go to the right position. But sometimes you have different results. For example, like this. This one over here, we have 3 centroid. Okay, over here we only have 1. So we will get different results. Okay. There are a few problems here. So the problem of having good clustering results, you need to have multiple run, and also how do we determine the best number of cluster? So in that case, they introduced DB scan and also hierarchical clustering, which solve the clustering. What is the best number of K? Okay. Okay. The problem with the K means can be illustrated if we have different size, different density, or non-globular shape, which where you have different shape of data that you have. Okay, for example, for this one we have different size. So we have the blue, the red, and the green. Okay, so if we use the k-means, we have something like this because they have different size, right? So the system or the algorithm will never know the size, but what they know is the location of each of the data that we have. Okay, with different density, we may have this different result again, or non-globular, so we may have this. Okay, so to solve this issue, they said, okay, why not we have more centroid to cover the data and then to have a compact cluster. So they said, okay, for this one, we will have 10 to cover different size, to cover different density, and to cover non-globular shape. Okay. Okay. Any question? If you okay, can you type number 2 in the chat? Okay. So any questions so far? Do you understand how the clustering method performing the clustering now? So you need to, what K refer to? K, what is K? What is K? When we say K mean clustering, what is K here? What is K? So the K here refer to what? Anybody can answer that? Number of cluster, right? Okay. So the K means refer to what? Means. So means is actually average, right? So basically we are the K refer to number of cluster, and we are looking at the centroid of the cluster by taking the average tool. Okay. Okay, so very good. You can proceed. Okay, so for us to look at the quality of the cluster, we can look at the compactness, or we can look at the how far they are separated. So this is very useful because we want to avoid finding pattern in noise, which means that if we have outlier, that is not good, right? And also we want to compare clustering algorithm, and also we want to compare two set of cluster, which one is better, or we want to compare how compact is the cluster. So we want to compare two cluster. Okay. So in order for us to look into the benchmarking or measurement, we have this. We have external index, we have internal index, we have relative index. Relative index used to compare two different clustering. So this is either we use external or we use internal. So the difference between these two, the internal referring to the structure, so which is looking at the compactness of your cluster. And also this Davis-Boolean index, they are looking at the compactness and also how far the cluster separated. Okay, and for this external index, they are looking at other things like the characteristic of the data, the label of the data, and so on. So this is looking at the class label. Okay, and they, in other name, they look at the cluster entropy. So the entropy referring to how pure is your cluster. Okay, with regards to the class label. Okay, so external index looking at the label of your data, internal index looking at the structure of your cluster. Okay, so both can be used to form the relative index. Okay, so let's take a look at how do we do the benchmarking. Okay, okay, for the cluster entropy, so this is looking at the level of membership for each of the item in the cluster. So basically, we are looking at the total entropy. Over here, we are looking at the what we define is the entropy for that particular cluster. So this one can be referred here, in which we are looking at the probability of having one symbol here. So we have S symbol here. So for each of the symbol, we are looking at the probability of having that particular symbol. And then we add up all those probability. So this is only for one cluster. So we will do it for the rest of the cluster. Okay. This is the rest of the cluster. Okay, and then we take the what we say the weightage. So this is the number of this is the number of group that we have. Okay, so no, this is the number of item that we have. This is the number of item in that particular cluster. Okay, let me give you one example here. Okay, can you see the cluster 1, 2, 3, and also the label of the data inside the cluster? And okay, so what we want to do is we want to find the how pure the benchmarking ataupun measurement that we can use to show the purity of the cluster. So over here we have 5A and then 2B. Okay, so the probability of having label A here is 5/7, right? This is the probability of having A. And then the probability of having B will be 2/7. Okay, so we use this probability to form the entropy measurement. Okay, so the formula is here. So for this one is actually the entropy for this. So this is the probability of having A, and this is the probability of having B. So we use this formula. Okay, we use log base 2. Okay, so we get some value here. Okay, for cluster 2, so we have 1A. So 1A is 1/9 because we have 9 data here, and then B is 1. We get 1/9 also, and then C 7/9. Then we get some value here. Okay, and for cluster 3, we have 1A, 2B, and 4C. Okay, so we have 1, and then 2, and then 4, and then we get the result here. Okay, so we have 3 entropy. So the total entropy for the cluster result will be the summation of all of them, but we need to look at the weightage. Okay, so the total member of all this will be 23 data that we have. Okay, so for the cluster 1, we looking at 7 member here over 23. So that is the weightage of entropy for cluster 1. And this is 9/23, this is 7/23. So we get the total entropy. Okay, so the lower the value is, the better, because if all of the member belong to one class, the entropy will be 0. Okay, so if we have 50/50, so the entropy will be 1. Okay, so we want to minimize the value of the total cluster entropy to show that we have a good clustering result. So that's how we use the formula. Okay, any question so far? Okay, can we proceed? So this is external index. They are looking at the label of the item. So now we are looking at the structure. So the structure here, internal measure. Okay, now we look at the Davis-Boolean. Okay, the sum of square error that we covered just now is a formula used to measure the compactness of the cluster, right? Okay, so this is another formula called Davis-Boolean index. They include the compactness and also how the cluster are separated, how far they are separated. Okay, so we call it DBI because it stands for Davis-Boolean index. So what happened is we will for each cluster that we have. So we have cluster 1 up to C. Okay, so for each of the cluster that we have, we will look into the compactness of that particular cluster with respect to another cluster, and also the distance of 2 clusters that we have. Okay, so we are looking at 2 clusters here at one time, and we look at the compactness and also the distance. Okay, so I will show you how to do this one. This one is used to find the center of the cluster. So no, this is used to find this figure refer to the center. This one is the compactness. So this is similar to the previous one. So what happened here is that, okay, I want to find the compactness of the cluster. So what happened is that I will take the average distance between that particular center to the rest of the member. So this is the compactness. This is the center between cluster. Okay, center between cluster, and this is the centroid. How do we find the centroid? Okay, so basically we are looking at the summation of all the member for that particular cluster I, and then we take the average. Okay, so to simulate the application of this formula, let's give you this idea. So here is the compactness, right? So we want to minimize that. This is the distance between cluster. So we want to maximize the value of intercluster. Okay. Okay. Let's suppose we have this data. So we have cluster 1, cluster 2, and cluster 3. Okay. So each cluster will have 3 data. Yeah, 1, 2, 3. So these are the value. And cluster 2 also have 3 member. Okay. So the first thing that we need to do is we need to find the center of each of the cluster. So our aim is to find the center. So how do you find the center? Is just taking the average of the summation of all the member values. Okay, so this is for the X, this is for the Y. And we get 1.3, 2.83. Okay. So for cluster 2, we also take the average. We get 3.5 and 0.67. And then C3, we have 4.83 and 6. Okay. Okay, wait. Okay, I'm back. Okay. So once we find the center of the cluster by taking the average of the value of X and Y, then we get this value, right? So we know where is the center. Okay. So next one will be, we want to find the distance between this cluster. So what are the distance? Okay. So we have the center. So now we want to find the distance between two cluster. So for distance between cluster 1 and 2, so we take the difference and then square them, add with the difference of this and square that. Okay, so this is 1.83, 3.5, and you take the square plus 2.83 minus 0.67, and you take the square of that value and you add up that together and take the square root, you get 2.7. So this is the distance between cluster 1 and cluster 2. You will repeat that one with cluster 1 and 3. One and 3, and then 2 and 3. So you get this value. Okay. So we keep this value. And then now, since we already have the center, we can measure the compactness, right? Okay. So now we measure the compactness here. So the compactness is similar to what we have done with the distance between the member. Okay, so we have this center, and we want to measure the distance between all the members that we have in this cluster to the center. Okay, so for this one, we take the difference between 1.83 with 2 and take the square, which is this one, and then take the 2.5 again with the 1.83 and also 2.5 from the 2.83. Yeah, this one. Then the last one is 1 and 3 is here. Okay. So we take all these differences and divide by 3, because the formula here we have number of members in that particular cluster. Then we get this 0.61. Okay, so we do again for cluster 2 and cluster 3. We take the average 0.43, 0.66. So this is the compactness of the cluster. So we have the center, okay, and the center will be used to compute the distance between cluster and also the compactness of the cluster. Okay, so once we get this value, then basically we are ready to find the dBi. Okay, so the formula for the dBi is like this, but if you look at here, they start from K1 up to C, so K1 up to 3. So we start with cluster 1 first. So cluster 1 here, they are colored in blue, and now we are looking at whether we are taking the value for this, the measurement K1 to K2 or K1 to K3. Okay. Okay. So we said for cluster 1, for each cluster which is not equal to 1, we find. So that means K1, K2, and K1 and K3. Okay, so first we look at the K1 and cluster 1 and cluster 2. So we take the compactness of cluster 1, compactness of cluster 2, divided by the distance between cluster 1 and 2. So we get this one from our previous calculation, and we get 0.38. Now we do it again for cluster 1 and cluster 3. Okay, so we plug in the value, we get 0.29. Okay, so now we want to pick this measurement or this measurement. Okay, they says that okay, we find the max. So the reason why we find the max is that because we want to take the worst scenario. So that means the cluster 1 CDBI, cluster 1 dBi will be 0.38, which is the maximum between these two measurements. Okay, we want to take the worst scenario. Okay, so this is only for k equal to 1. So now we go for k equal to 2. So you notice that the color is different right now. So now we are looking at cluster 2 against the other cluster. So we do it again for this. So for cluster 2 and 1, basically they are the same because we are doing the same, but only the other way around. Okay, and also cluster 2 and 3. So we plug in the value and we get 0.2. Okay, so this one's supposed to be 2. So this one's supposed to be 2. This is 2, right? And this is 3. Okay. Okay, so for the cluster 2, the dBi would be 0.38. Okay, because we are looking at whether we want to say what is the worst scenario here. So basically, the worst scenario is between cluster 1 and cluster 2. Okay, and then next one will be 3, the cluster 3 here. Okay, so for cluster 3 and 1, we get 0.29. Cluster 3 and 2, we get 0.2. Okay, so we take the worst scenario, so we will take 0.29. Okay, so that is for all the mean that we get. So we need to add up all this value and divide by 3 because of this. So we get 0.38, 0.38, 0.29, and divide by 3 because we have C here. So this is the average. Okay, so this is the quality of the cluster. So the aim is we want to reduce this, and maximize this. So when you look at the value here, the value must be minimized overall. So the lower the better. If you have higher, means you are getting bad cluster result. Okay. So the calculation is quite tedious because you need to do every cluster that you have. But don't worry, I will give you the first assignment for this course. So given the cluster, you need to compute the dBi value of that particular cluster. Okay, any question?